Good. Once we found the center position, now let's do some averaging for the analysis. So here you can use the sax tool. Click this one. Okay, then you will see this one. Uh, the first step is we need to make a Q map. Just click this button. Then on the MATLAB main terminal, you will see a message Q map and theta map are ready. Okay, so probably in a second it's done. Next step is you want to put the intensity limit. Intensity lower than 0 will not be counted. Also, intensity higher than 2 million in this image will not be counted. Okay. If you have a mask images, you can load the mask image. Load and pick like this. So I did. Good. And then that's the directory for the average data. So you can change it like this. Average the data will be saved under AVG or whatever the name of the subdirectory. You can put it in. Okay, good. So there are two different way of averaging data. So first way is Q versus intensity, which is typical, Sachs plot, and another one is the theta versus IQ, which is azimuthal kind of integration. So first the step for this image, let's just say I want to average the data. Then you click this button, and then average the data will be saved, displayed under, let's say, graph number 2 and log plot. And so make sure you want to plot. Okay, you don't want to plot, and you want to plot. Okay, click on it, and you see the average the pattern for this image. Okay. Hmm. Now, the other step, other analysis, what we want to do is we want to do the sector averaging of around maybe this peak, right? That's the peak is location is about the 45 degree. So let's say minus 40 degree to 50 degree. Not the minus 40, just the 40 to 50 degree. Show me. So then it will show you the kind of angular range. Okay, maybe you want to go 30, 35 for this peak and maybe 52-ish. Okay, clear and show. Okay, those are the range, for example. Okay, and then click on it. Then it will overwrite, not overwrite, it will overlay the new average data onto the existing graph number 2, right? But but the average the data name is different. The standard way of averaging is using the file name as average the data name. But when you do the sector averaging, software will add the dash sector underscore 35 to 40, 52. So the range you actually picked, right? Good. If you look at the intensity here, so this peak actually comes from these 4 peak, okay, is not included as you see here. And also the intensity of this peak, which is here, is a little higher than the full averaging, is because so when you do the full averaging, the intensity of this 4 peak, 1, 2, 3, 4 peaks are spread around the entire 360 degree. But for the green curve, this one peak intensity is spread around from, let's say, 35 to 52 degree in this range. So the mean intensity, of course, will be higher, right? Like this. Good. Now, so if you're happy with this, let's try now the azimuthal averaging along the so averaging the data intensity along the q direction, but you plotting as a function of a theta, right? Okay, so let's pick the q range maybe. So, oh, okay. Before doing that, let's do the sector averaging also around this empty area. Okay, so clear up. Let's say maybe from 10 degree to 35 degree. Okay, those empty area. Okay, so if I do the sector averaging around there, so it will be red curve. As you see, the background level is the same for all this data, but difference also is a kind of in the middle range here. Although you cannot see anything in the images, there are some weak broad peaks in this range as well. Okay, which is kind of appears as like the red curve here, right? Okay, now I want to do the actually azimuthal integration from all the way to kind of from this here to that end, so including entire broad red peaks. Okay, so now the let's pick the Q range. So I like to include the Q range. Maybe you can Q range include everywhere, but the peak is actually very sharp. I'm not sure about what the kind of details are. But let's just say we're gonna start from here. Q equals 0.11 to somewhere here 0.016. Okay, 0.011 to 0.016. That's the kind of Q range I want to integrate. Pretty wide range. Let me remove this. Let's clear up the data, and then also you can see the Q you can see the actually Q range. So these region will be integrated together. Okay, good. If you're happy with the Q range, you select it. Oh, so you pick this mode, theta versus IQ mode, and click the same button. So now we're gonna plot the intensity to maybe the same figure 2, but in this case linear plot, linear plot. Click it. Then you can see the average the intensity. The final intensity is kind of plotted as a function of a radian, not the degree, but it's good. But sometimes, this resolution here is maybe too fine. So instead of plotting the data every 1 degree step, let's plot the intensity every 2 degree step. Okay, so click on it, and then you will see the green curve. So green curve is of course a little bit broader because we reduce the resolution, and then you will see the less number of data point anyway also. Okay, good. And all this integrated data is already saved with the file name shown here, and always file name and then dash, so new addition. In case of the sector averaging will be sector, azimuthal averaging is azim underscore, and the Q ranges will follow. Okay, um, that's about it.